All right, here we go. Describe the motion. This object is accelerating and the velocity is changing. It's accelerating because this is a distance over time graph and this is curved. What is the average velocity from 0 to 5 seconds? So 0 to 5, we go up to here, it went 40. So you can just pretend that the line is like that. You can say velocity equals distance over time. It went 40 meters in 5 seconds, so 8 meters per second. Number 3 we can't do because it's curved. What would be the accelerate? Oh yeah, okay, never mind, I erased the wrong part. It's this one we can't do. Sorry, I got ahead of myself, kids. We just can't do this one. All right, what would be the we can't do that one. What would be the acceleration 0 to 1.5? So 0 to 1.5. So in 1.5 seconds, it's going, if this was velocity now, it went from 0 to 5 in 1.5 seconds. So acceleration is equal to change in velocity, sped up by 5 meters per second in 1.5 seconds. So just calculate that. 5 divided by 1.5, 3.33. Sorry, kids, I'm trying to go fast, and I think that's making me not be as clear. What would be the instantaneous acceleration of the car at 4 seconds? You would just go to 4, you'd kind of put a dot there at 4, and you would try to just continue on with that and find the slope of the line. The slope of the line on a velocity over time graph is the acceleration. So whatever that slope was, that will be hard to get down exactly. Like I said, we couldn't do that one because this is curved. Number 4, the bike travels 5.2 meters per second for 3 minutes. How far does it go? Velocity is equal to distance over time. Went 5.2 meters per second for 180 seconds. Took my calculator. 5.2 times 180, 936 meters. How far does this object travel from 200 to 600 seconds? So 200 to 600, and then we're just going to be like, all right, the area under the line. So this is 200 and it goes up by 20. So the area of this is 1/2 200 times 20, so it'd be 2,000 right there, and then this one is 200 by 20, so that'd be 4,000. So 2,000 plus 4,000 is 6,000 meters. Isaac threw a ball. It was in the air for 4.7 seconds. How high did it get? If you throw a ball in the air, it goes up for this long, it goes up for 2.35 seconds, and it goes down for 2.35 seconds. At the top, it's going 0, it stops. How high did it get? You could say xf equals 1/2 at squared. 1/2 of 9.8 because we're on Earth, and the t is going to be just how long it took to fall or go up. It doesn't matter, you'll get the same answer either way. So that is going to be 2.35 squared. Check my calculator. 0.5 times 9.8 times 2.35 squared equals 27. 27.1 or 27.06 meters. How fast was it falling when it hit the ground? Well, it accelerated at 9.8. It was at a dead stop at the top, so just accelerate at 9.8 for 2.35 seconds. Like, that's it. 9.8 times 2.35. It's going 23 meters per second when it hit the ground. A train with a velocity of 60 meters per second must come to a stop in 11 seconds. If it slows at a constant acceleration, what would that acceleration be? We could just say xf equals 1/2 at squared, right? Now, how would we get the a? Well, we would say it went from 60 to 0 in 11 seconds. So we need to use this formula. And we would say the change in velocity was 60 in 11 seconds. So we could be like, all right, 60 divided by 11, give me 5.45. So the acceleration, we could say xf equals 1/2 5.45 times 11 squared. That'll give us an answer, or we could use this other formula, vf squared equals vi squared plus 2a delta x. The final velocity was 0. The initial velocity was 60. 60 squared plus 2 times a. Well, we don't want to use this one because, well, we would have to put this acceleration into here, 5.45, 2 times 5.45 times the x, and then we could solve for x there. We'd have to move a bunch of stuff around. 2 times 5.45x is going to give me 10.9x. 10.9x plus 60 squared equals 0. And then we'll have to say, yeah, it's slowing down. The acceleration was negative, right? Isn't it a negative acceleration? So we can say negative this, move it over here. 60 squared equals 10.9x. Again, kids, I'm sorry I'm going so fast. 60 squared divided by 10.9 gives me 330 meters. And if you do this problem right here, also gives you the exact same answer. I suggest you do that one, but either way, you got to calculate the acceleration yourself because it's not given to you. Number 8. What is the average acceleration of the object in the graph from 0 to 6 seconds? 0 to 6. All right, look. You don't care about any of this stuff. You're just looking at the average. It went from 0 to 3 in 6 seconds. Acceleration equals change in velocity over time. So 0.5 meters per second is the average velocity. Number 9, skater skates. All right, we know this. xf equals xi plus vit plus 1/2 at squared. All right. He skates at a constant velocity, skater rolls 3.2 for 1 minute. This is how far we've gone before we come to the hill. So we're going to say 3.2 times 60. 3.2 meters per second for 60 seconds. Plus, and now this part of the problem is us on the hill. How fast is he going when he gets to the hill? That's our initial velocity. That's going to be 3.2. How long is he on the hill? 21 seconds. 3.2 times 21 plus 1/2. His acceleration is 0.09. 0.09 times 21 squared. Okay? In this example, he's going faster. He's going to a decline, which means the skater is skating, and then he goes downhill, so he's speeding up. So the number right here for acceleration is positive. If he was going uphill, then we would have a negative number here, and this would end up being minus. I think most of you know what I'm talking about. Let's get this number right here, 3.2 times 60. I know what that is. We want to hit that in there, 192 plus, let's do this guy in the bracket, 3.2 times 21, 3.2 times 21, 67.2 plus 1/2 0.09 times 21 squared. Let me calculate that. 21 squared times 0.09 times 0.5 equals 19.8. So we're going to add all these numbers together. 19.845 plus 67.2 plus 192 gives them a total distance of 279 meters. All right. A runner runs at a constant velocity, 2.7 meters per second. Right, now this is going to be our y is equal to mx plus b, right? Except for we use xf equals vt plus xi, right? Okay, runner runs at 2.7, so our first runner's velocity is 2.7, and he has a 12-meter head start. 2.7 for a certain amount of time plus a 12-meter head start. Now, when another runner starts at the same time, she runs at 3.1, at what distance and time would it take for them to catch? So that means we can set these two equal to each other. The next person's VT plus XI is the girl that's running faster. She runs at 3.1 for a certain amount of time, and she has no head start. So we're going to solve for these two. I'm going to mark that out. I'm going to solve for our t. I'm going to subtract 2.7t from both sides. So give me 0.4t equals 12. 12 divided by 0.4 gives me the time. It's going to be 30. 30 seconds is how long that's going to take. Let me brain this out. 12 divided by 0.4 just to make sure I'm not an idiot. All right. 30 seconds. 30 seconds is how long it would take. What distance? Well, the simplest formula, we throw this back into the formula. The girl ran at 3.1 meters per second for a certain amount of time. That amount of time was 30 seconds. So we just say 30 times 3.1. She ran 93 meters. That is where the pass occurred. We also could create a graph. The graph would look like this. I'm just going to make a graph that's qualitative. The slower person started up here. This is their head start of 12. Does that make sense? And then the other person, they both started at t equals 0. And the other person ran a little bit faster and caught them. And that would be right here. That would be 30 seconds. And this time, which I really kind of screwed up, this distance would be 93 meters down the track. So evidently this is one of those graphs that's not. You get the idea. A red remote control truck is used in a physics experiment. How could you calculate the speed of the truck in tiles per second? You make a track. You know how far that track is. You time how long it takes the car to go that distance. And you say velocity is equal to distance divided by time. That's it. Describe the motion of the truck over time. It's going faster at first. It's accelerating, and then it's still accelerating, but at a slower rate. Its velocity is increasing, but at time equals x, remains increasing, but at a lesser rate. What is the average velocity from 300 to 500? 300 would be right here. 500 would be right here, okay? The velocity, right here, velocity, we would just go from here to here. Does that make sense? We're not calculating distance. We're just saying at 300 they were going 10. At 500 they were going 20. So what is the average velocity from 300 to 500 seconds? Oh, I see what they wanted to do. They want here's what I wanted you to do originally, was just to calculate this whole thing. You can calculate the total distance and be like, there's a triangle, here's a rectangle, here's a square. And then you can find your distance and say velocity equals distance divided by time. Does that make sense? Because this is how long it takes, 200 seconds. So we'll calculate this. This is 100 by 10. So 1/2 100 times 10 is 50. Right? Excuse me, it's 500. So 500. And then this is 100 by 10. That's 1,000. And this is 200 by 10. That's 2,000. So the total distance they went was 3,500 meters. And it took them from 300 to 500, it took them 200 seconds. So their average velocity in there was 3,500 divided by 200. 17.5 meters per second. That was kind of cool. Describe the motion of the truck over time. All right. Is this a velocity? If this is a velocity over time graph, what is the average acceleration of the bike between 2 and 4 seconds? So it goes from 1 to 3 in 2 seconds. The change in velocity was 3 and then it went to 1. This is VF minus VI, and then this happened over 2 seconds. Acceleration is equal to change in velocity over change in time. 3 minus 1 is 2. 2 over 2 is 1. The average acceleration was 1 meter per second per second. Does that make sense? I'm sorry if I was off the bottom of the camera there. Man, I'm going so fast. I don't know how helpful I'm being. In the graph above, how far is the object gone after 40 seconds? Go right here, 40. It's velocity over time, so we'll just make this 20 by 40. That's 800. This is 20 by 40, but half of that is 400. 400 plus 800 is 1,200. A runner maintains, so another runner, so we've already done one of those, you can do it. What is this person's average speed from 0 to 0.4 seconds? 0 to 0.4 seconds. Their average speed would be the slope of this line, right? Or you can just say